Question number 26. Let us consider the function fx, which is defined as fx equal to c into e to the power minus x to the power 4. X belongs to R, and we need to find the value of c, for which f is a PDF. We know that for fx to be a PDF, then c into e to the power minus x4, this has to be greater than 0, which is obviously true for any c greater than 0. And integral minus infinity to infinity, c into e to the power minus x to the power 4 dx is equal to 1. We can observe that this integral is symmetric about 0. So if we simply consider the positive part of the integral, this becomes twice c into integral 0 to infinity e to the power minus x to the power 4 dx, which is equal to 1. Now we substitute x to the power 4 is equal to t. So 4x cubed dx is dt. And here it is twice c into e to the power minus t. And dx is obviously dt by 4x cubed, which is dt by 4 into e to the power 3 by 4, which is equal to 1. So this 2 and 4 get cancelled. So it's c by 2 into integral 0 to infinity. We can write t to the power minus 3 by 4 as t to the power 1 by 4 minus 1 into e to the power minus t dt, which is equal to 1. And this is the form of the well-known gamma integral. So we can substitute this as c by 2 into gamma 1 by 4, which is equal to 1. So c is 2 by gamma 1 by 4. And from the options, we can observe that option A is the correct one.
Hello guys, welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT MS, ISI Mstat, and CMI MSc Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses. To book a trial class for your preparation courses of IIT MS, ISI Mstat, and CMI MSc Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.
So question number 27, it talks about 5 IID random variables x1, x2 to x5 who have a continuous distribution function. And then we have to check that the probability x1 greater than x2 greater than x3 greater than x4 greater than x5, given that x1 is the maximum of these 5 quantities. So essentially, this is a question involving both conditional probability and order statistics. So now, by the rule of conditional probability, we know that this can be written as probability x1 greater than x2 greater than x3 greater than x4 greater than x5, comma x1 is the maximum, divided by probability x1 is the maximum. And x order 5 is simply the max. It's a notation. It means that x1 is the maximum of these 5 elements. And obviously, in the numerator, x1 is greater than x2 greater than x3 and so on. This intersection x1 is the maximum of these 5 is equal to this same quantity again, because this is a superset, because the denominator, this is a superset of this quantity, probability x1 greater than x2 greater than x3. And since all the random variables have equal probability of being the maximum, then probability x1 is the maximum is equal to 1 by 5, because any of the 5 random variables can be chosen to be the maximum. And these 5 random variables can be arranged in a total of 5 factorial ways. And this ordering x1, x2, x3, x4, x5 is a particular one out of those 5 factorial ways. So the probability of this ordering occurring is 1 by 5 factorial. So our required probability is 1 by 5 factorial by 1 by 5, which is 1 by 4 factorial, which is equivalent to option C. So Now we have a vector space V of real valued continuous functions on the closed interval 0 to 1. W is the subspace of V spanned by sin x, cos x, tan x, and we need to find a dimension of W over. So essentially, the dimension of W over R means the number of vectors in the basis of the sin x, cos x, tan x, or we can also interpret it like the number of independent functions in the among sin x, cos x, and tan x. So first we will try to check whether they are independent or not, and if not, then we'll proceed in some other way. So I've simply written down the notations here, V and W, and we first check if sin x, cos x, and tan x, they're independent. This set is independent. So as we know, the definition of independence for a set of vectors is, for this case, is a sin x plus b cos x plus c tan x equal to 0. This implies a is equal to b is equal to c is equal to 0. If this condition holds, then we can say that these three are independent. So I have done just that. I have here considered a sin x plus b cos x plus c tan x equal to 0 for some real scalars a, b, c, and we will try to find out the values of a, b, and c. And since the functions are defined for all x in the range 0 to 1, so first we consider x equal to 0. So a sin x is a into 0 plus b cos x is b into 1 plus c tan x is c into 0, which is equal to 0. So b is equal to 0. For x equal to pi by 4, we next consider the next value of x to pi by 4. Then a by root a sin x a by root 2, and b is already 0 from this equation, and c tan x is c. So a root 2 plus c is equal to 0. So c is equal to minus a by root 2. For x equal to pi by 6, a sin x plus c tan x comes out to be a by root 2 plus c by root 3, which is equal to 0. And from earlier, we have obtained that c is equal to minus a by root 2. So we simply substitute it here, and we obtain a by root 2 minus a by root 6 is equal to 0, which simplifies to a is equal to 0. And since c is equal to minus a by root 2, and c is 0 as well. So we have observed that a is equal to b is equal to c is equal to 0. If a sin x plus b cos x plus c tan x equal to 0, so sin x, cos x, tan x, this set is linearly independent, and therefore we can consider the dimension of this subspace, which is spanned by sin x, cos x, and tan x, to be equal to 3. Okay, any questions?